Okay, so we're going to talk about solution concentration, and here we're typically talking about dissolving a solute or solid solute into water usually. And so we can talk about solutions qualitatively. We can say they are concentrated or they are dilute, or we can talk about them quantitatively. And there's a variety of ways to talk about them quantitatively, numerically. The one that is most common is molarity, and that's what we're going to use mostly in the class. And molarity is moles over liters. Okay, so molarity is just one way to measure the concentration of a solution, and it's a big M. It's not a little m, because that actually means something different. Molality, which we are not learning in this course. Okay, so it's the moles of the solute, the thing that I'm dissolving, over the volume of the solution in liters. And usually we're talking about water, and that solution is going to be known as aqueous. So if I were to rearrange this equation, the moles of the solute is molarity times liters. Now, one convention that gets used in AP Chem a lot is this bracket, and anything inside the bracket, if I put a substance in there, it's talking about the molarity of that substance. Okay. So here I am. One of the things we're going to do the first week of school is you're going to learn how to make a solution. You may have already done it in Honors Chem, but we'll just make sure you know how to do it for AP Chem, because we do this a lot. There's only one piece of glassware we use for making a solution, and it's called a volumetric flask. It's not an Erlenmeyer flask. It's not an ordinary flask. It's a volumetric flask. And that's important because the volumetric flask is very precise. And I have different types of volumetric flasks. I can have a 1 liter flask, I can have a 100 milliliter flask, I can have a 500 milliliter flask. And what you'll see is each flask has just one tick mark on it, just one line. Okay? And you are making a solution. If you're making 1 liter, you get a 1 liter flask. If you're making 100 milliliters, you get a 100 milliliter flask. Okay, so here I need to prepare 1 liter of a 1 molar sodium chloride solution. So the molarity is 1, and I have 1 liter. I'm going to need 1 mole, right? Whoops. So what I'm going to do is I'm first going to weigh out 1 mole of sodium chloride, and because its mass is 58.44 grams per mole, I'm going to add the 58.44 grams to the empty volumetric flask. And then I'm going to add water up to the line. I need to mix it, right? We'll use a magnetic stirrer. Sometimes you can just cap it with some parafilm and then invert it several times. But the important thing is that you are adding to a total of 1 liter. So you might get asked, well, which is the correct procedure? Am I adding water to the 1 liter mark, or am I adding 1 liter of water? And they're actually different. I'm not actually adding 1 liter of water to this. I am adding water to the 1 liter mark. And that's because this solid takes up some of the volume, not a lot, but some volume. So you want to make sure the final volume is 1 liter. Alright, so here we want to calculate how many grams of magnesium nitrate are required to make 500 milliliters of a 0.672 molar solution. Alright, so remember, molar is equal to moles over liters. Okay, so I could use this as a conversion factor. It would be 0.672 moles of magnesium nitrate per 1 liter of solution, right? Alright, so let's go ahead and use factor label to solve this problem. So if I'm making 500 milliliters, that's what I'm going to start with. And I don't start with molarity because that's a conversion factor. And so I'm going to convert milliliters to 1 liter. And what I know, I can put this factor in now. 1 liter is 0.672 moles of magnesium nitrate. And I want grams, so what I know is 1 mole of magnesium nitrate. If I found the molar mass is going to be 148.30 grams. Alright, so everything will cancel out now, right? And I end up with 49.8 grams of magnesium nitrate. I want 3 sig figs because that's what I have in the problem. Okay. Alright, now we want to know what is the concentration of sodium ions if 3.21 grams of sodium phosphate is added to water. Okay, so if I have 3.21 grams of sodium, phosphate's a -3, so I need 3 sodiums, right? What I can do is figure out how many moles that is, right? So it's 163.94 grams is 1 mole of sodium phosphate. Now what I also know is this asking about sodium ions is for 1 mole of sodium phosphate there are 3 moles of sodium ions. Okay, so if I multiply that out, I have 0.05874 moles of sodium ions. Okay, but it's asking about molarity, so molarity is moles over liters, so it's 0.05874 moles over, now I have 800 milliliters, so 800 milliliters, and I divide that by 1,000 milliliters in 1 liter, and I get 0.8 liters. I divide it out, and I get 0.0734 molar. I need 3 sig figs because my values in my problem are 3 sig figs, so that is 3 sig figs.